Hola amigos, now let's continue with conic sections and Kepler laws. So here we have conic sections which is left in the previous lecture. Here we have hyperbola, parabola, ellipse and circle. In circular orbit in which a satellite is revolving around the earth, we can see it is revolving with velocity vc, which is having a semi-major axis equal to the radius of the orbit. And here we have a semi-major axis greater than 0, and here in parabola we have semi-major axis which tends to infinity, and in hyperbola we have semi-major axis which is negative or less than 0. And velocity wise we will see in a circular orbit velocity is given by vc. In parabola, velocity of the satellite which is following the parabolic trajectory is given by vp, and the velocity of the elliptical orbit which is following the elliptical orbit is given by v, which lies between the parabolic escape velocity and the circular velocity. So here also we have the hyperbola, which shows that velocity of the satellite following the hyperbolic trajectory is greater than the vp, that is the velocity of hyperbolic trajectory is greater than velocity of satellite in the parabolic trajectory, which is minimum escape velocity. So let's continue with Kepler laws now. There are three main points in Kepler laws. The first point is that all the planets move around sun in elliptical orbit having sun at one of the foci, and the second is a radius vector joining any point to the sun sweeps equal area in equal interval of time. And third, the square of time period of revolution of this planet is directly proportional to the cube of its mean distance from the sun. The total mechanical energy of a planet revolving around the sun will remain the same or is conserved because the gravitational force is a conservation force, and the total mechanical energy is sum of kinetic energy and potential energy. Kinetic energy half mv square, potential energy minus dmm by r. And since it is a constant between any 2 points in an orbit, whatever may be the orbit, elliptical or circular, we have this mechanical energy at point 1 and 2 always the same, which is constant. And therefore at any point we can say r1 v1 equals to r2 v2, which is actually the angular momentum per unit mass, as we have seen over here. Here h is angular momentum per unit mass. h1 at point 1 and h2 at point 2 both will be same because angular momentum remains conserved. That's why we can place any number of satellites in the same orbit. Okay, and dA by dt, amount of area swept, is equal to the angular momentum per unit mass divided by 2. And angular momentum is also conserved since we know that L equals m into r cross v. So this is constant, which is also equal to mvr into sine gamma, and gamma is the angle between the radial vector and the velocity at that point. And r cross v, as we have seen here, is equal to angular momentum per unit mass. So when it is multiplied by mass, it becomes angular momentum. And angular momentum, we can say that mvr for a circular orbit, gamma equals to 90 degree. So angular momentum will be mvr, which is m into h. And mvr, and in this if we replace v by v perpendicular, and in terms of omega we substitute this, it becomes mr square omega, and mr square is equal to I. So L equals to I omega, which is also constant. So between any 2 points, I1w1 equals to I2w2, and omega is the angular velocity, which is rate of change of angle with time. D theta by dt equals to 2 pi by t, or 2 pi n. N is frequency, 2 pi f you can also say. And v in an elliptical orbit is actually the sum of square of velocities, perpendicular velocities and parallel velocity, perpendicular to the radial vector and parallel to the radial vector, v perpendicular and v parallel velocities. So this is the resultant velocity v over here. And for the circular orbit we only have v perpendicular because v parallel is 0 in circular orbit. So and the last thing is the torque that can be applied by the central mass on the satellite revolving around it, by dl by dt. The torque will be 0 because angular momentum is conserved. So, and since angular momentum is conserved, so there will be no change in angular momentum with time, so there will be no torque. That's why torque tau equals 0. Thank you.